Hello, this is IT Taro. This time, I would like to investigate the motion sensor. In the future, we are also considering applied applications such as using the motion sensor to operate the camera installed at the entrance. This time, we will check the mechanism and specifications of the motion sensor and understand programming. As for the performance of the sensor itself, there is a manufacturer's data sheet, so I think that it is correct data without any mistakes to refer to the content of that. Here, I will introduce it as an example of electronic work using ESP32. Let's move on to the table of contents. Here is the table of contents. First, let's understand how the motion sensor works. Check the list of sensors to be investigated in the second item. In terms of specifications, we also briefly summarize what kind of product it is. The third item is to check the specifications of the ESP32 ports used, and then check the main specifications of each sensor required for use. For the fifth item, we conducted a simple usage survey for the sensor-only type to determine whether it can be used. The sixth item is to understand the circuit for measurement, then the programming, and finally the measurement results. Move on. Although it is a motion sensor, it seems to detect changes in the infrared rays emitted by objects and react to moving objects. All things seem to emit infrared rays, but the wavelength varies depending on the temperature. It seems to be a sensor that uses the principle that when the wavelength of the infrared rays changes, the temperature of the pyroelectric element changes, and the output voltage of the sensor changes. When I think of infrared rays, I had an image of warm objects, but I was wondering if it would react to cold objects, so I decided to check it out. We will present the measurement results. Move on. Here is a list of motion sensors to be investigated. We choose from nearby stores and reliable mail order sites. We have excluded overseas mail order sites because there is a possibility that sensors that are not genuine products may be delivered. 3.3 volts or 5 volts can be used, and I chose the one with the lowest price. However, we limit up to 3 products that are considered to be of the same type. This is the result of selecting up to 3 products for each product that looks like a different type. I would like to check these 8 products. Move on. First of all, we divided the types into 3 types based on the confirmed specifications. A product that has a motion sensor attached to the substrate and is modularized by integrating elements such as resistors. A product that integrates a Fresnel lens and a sensor. Next is the product of the sensor unit. After purchasing, I noticed that the third sensor-only product is the cheapest, but it seems that an operational amplifier is required to use it. When you actually make an operational amplifier, you can't buy just one breadboard, IC, and resistors, so one pack of 100 pieces costs 100 yen. In the future, when actually using a motion sensor, I thought that creating and using an operational amplifier would not normally be selected in terms of cost and work. Therefore, the price is the same, but the method of use is X. However, since I bought it with much effort, I tried to see if I could use the motion sensor at a low cost, even if it was a simple method, so I will share it later. Move on. Since the sensor itself requires a Fresnel lens, I purchased this 40 yen product and attached it. This size may be standard. All 3 were really good. I'm going to put this lens on and measure it. Move on. Check the specifications of the ESP32 terminals used for measurement. Since the motion sensor changes the voltage when it senses it, the voltage is measured using the ADC terminal. Abbreviation for analog, digital, converter. Normal terminals are digital, and high and low can be identified. You can get the analog voltage from 0 to 3.3 volts and numbers from 0 to 4095. An 11 decibels attenuator is inserted as standard, so it is possible to measure from 0 to 3.3 volts, but setting this attenuator to 0 enables measurement from 0 to 1 volt. Since 11 decibels is about 3.5 times, it becomes such a relationship. Attenuator settings are programmable. The standard resolution is 12 bits, from 0 to 4095, but if you change it to 10 bits, you can get from 0 to 1023. Since there is no particular need to change this time, we will use the default. ESP32 has 2 ADC circuits. However, as a point of caution, I think that the limitation that the second ADC circuit cannot be used with Wi-Fi has not been improved yet. Since 2 ADC circuits are used this time, the network cannot be used, and the data is acquired by displaying the data on the serial monitor. If the motion sensor outputs 3 volts when it senses, we will measure with the normal PO terminal without using the ADC circuit. We will understand a little more in the next slide. Move on. When ESP32 is used as an input terminal, it is identified by high and low digital. I'm looking at the range of voltages identified from the ESP32 datasheet. As shown in the lower left, low judgment is 0.825 volts or less, and high identification is 2.475 volts or more. If the sensor has an output of about 3 volts, it can be identified by using the input setting. As a reference, the output current is 40 milliamperes, so devices that operate with a small current such as an LED can be used by connecting them as they are. If a large current is required, such as a motor, it must be amplified by using a transistor or the like. Move on. Let's check the specifications of each sensor. Although it is SB412, this sensor has a board attached. From the datasheet, it seems that voltage regulators, resistors, and capacitors are mainly installed. Voltage regulators are used to limit voltages above 3 volts, such as 12 volts and 5 volts, to 3 volts. The variable resistor is for changing the delay time, and even the smallest one is 1.8 seconds. Since the output voltage at the time of sensing is 3 volts, it seems that the amplifier is built in. It seems that it can be used with PO digital input. Move on. Next, here is the sensor made by Panasonic. According to the datasheet, the detection performance is different, but the electrical characteristics are the same, so it seems that the two sensors themselves are exactly the same. Only the Fresnel lens looks different from the outside. An amplifier is also built in and the signal output is half a volt below the supply voltage. I also checked with a tester, but I was able to measure the voltage as specified. When using it, it seems to be used by installing a pull-down resistor, so the resistor is built into the circuit. Move on. This is Grove's motion sensor. The sensor seems to be using a product called BS312. Checking the block diagram, it seems that an amplifier is built in and an output of about 3 volts can be obtained. The official website also describes the program used, and it can be used with normal input settings. The visible board mainly contains voltage regulators, resistors, capacitors, etc., but it seems that all the important functions are inside the BS312. Move on. This product is a sensor only. According to the datasheet, it is supposed to be amplified to 72.5 decibels. This means that it is amplified about 4,000 times. In addition, the signal line is used with a pull-down resistor attached to the ground. As an example of use, there is a configuration that includes an amplifier, so I will check it on the next slide. Move on. Here is an example of use described in the datasheet. It seems to be used by amplifying it about 4,000 times with a 2-stage operational amplifier. As I checked in the list of sensors, considering breadboards, ICs, resistors, capacitors, etc. to build an operational amplifier circuit, it is costly to make an amplifier for an individual to use a motion sensor. Since it is difficult to choose from a physical point of view, we will consider whether it can be used easily this time. A simple method is to try to measure the voltage change at the ESP32's ADC terminal. Since the voltage will be small, there will be variations, so I will try to determine if it is possible to determine a change of a few MV by averaging several times. I'll check the results later. Move on. This AIC1 sensor is also used through an amplifier as before. Use a 3.3 volts power supply by connecting a pull-down resistor to the signal output. We will also consider whether it can be used easily. Move on. This D205B sensor will also be used via an amplifier as before. Use a 3.3 volts power supply by connecting a pull-down resistor to the signal output. We will also consider whether it can be used easily. Move on. It will be the motion sensor of M5 stack. When it senses it, it outputs a voltage of about 3 volts, so it can be used with a normal input terminal. For ESP32 usage terminal, set input pull up. When set by programming, the corresponding terminal will be pulled up to high inside the ESP32. Move on. Here is a summary of the main specifications of the sensor used this time. When working with electronics, it is necessary to work without mistaking the operating voltage and the use of pull up or pull down. Move on. The sensor only type requires an amplifier, but we investigated whether it could be used simply. We will measure the output voltage of the sensor with the ESP32's ADC terminal and check whether changes can be detected. The circuit supplies 3.3 volts power to the sensor and wires a pull-down resistor to the signal line. I assembled the circuit so that it can be visually confirmed by turning on the LED when it senses it. Move on. Via program. Since the voltage changes are small, the program compares the average of the past 10 times with the latest value to reduce variations. There is no basis for averaging 10 times. First of all, we will try to see if we can judge with such an average value. Also, this time, if there is a change of 7 millivolts, it will be judged. This confirms the voltage that has already been measured, and temporarily sets a value that is likely to be detected. I think that it will be possible to use these values by trial and error. Move on. Regarding the contents of the sensor only, you can confirm that the voltage rises as you approach. From what I've checked, an increase of about 7 mV seems good, so I tentatively set the previous program to 7 mV. However, it seems to be difficult to use because it often generates 7 mV or more even when left unattended. Also, it seems that 7 mV detection does not appear unless there is a slightly large change. Therefore, it seems difficult to use it for sensing unless it can identify smaller voltage changes. I tried it, but decided that it would be difficult to use the sensor alone without an amplifier. Move on. It was difficult to use the 3 sensor-only products with a simple method, so we will proceed with the investigation with the remaining sensors. Move on. This is the circuit to measure the motion sensor of Grove and M5 stack. It supplies an operating voltage of 3.3 volts and detects the 3 volts output at the PO pin during sensing. The circuit is configured so that the LED lights up at the time of detection. M5 stack requires pull-up, but it is done by program, so we do not connect resistors. Move on. This is the circuit to measure the remaining 3 sensors. As before, supply 3.3 volts or 5 volts power, and detect the 3 volts voltage of the signal with PO. The LED will light up when detected. 2 sensors made by Panasonic connect resistance and pull down. As a reference, I checked whether pull down can also be done programmatically. It compiles and writes fine, but detection didn't work. I was able to program pull up, but for pull down, I may have to connect a resistor. Move on. Here is the program used for the measurement. Since it will be a simple content, only the operation overview will be confirmed. It checks the signal line voltage of the wired sensor every second and acquires high or low. When the sensor senses it, it will output 3 volts, so it will be high or true, and when it is not sensing it will be low or false. The acquired sensing result is a program to check with LED and serial monitor. Move on. Here are the measurement results. First, we measured cold object detection. I put the frozen ice pack in vinyl and hung it with a stick about 1 meter in front and moved it to measure it. Measured indoors. As a result, we were able to confirm that all sensors can detect even cold objects without any problems. Move on. Next, we checked whether it could detect even small objects. It seems that it is difficult to perceive at about 1 meter. It was detected when it moved about 50 centimeters in front. Distances around here varied slightly between sensors, but since it's difficult to move the drone at a fixed distance, the distances are also approximate. There is a video of the measurement content, so let's check it out. I think Grove and Panasonic had slightly better sensitivity, but it fluctuated a little and there was no big difference, so I generally set it to 50 centimeters. Since the temperature difference between the room temperature and the drone is about the same, it is difficult to detect, and the Fresnel lens widens the field of view, so I think it will be difficult to react to small objects. Also, I think that the comparator deliberately does not make judgments unless there is a certain amount of change, so as not to cause false detections even if the plants are swayed by the wind. So, it seems that it will react to unintended things so that small things can be detected, leading to false positives. I think that it is better to respond to the content that you want to detect that matches your purpose, so this measurement is not evaluated as good or bad, but as a single piece of information. Move on. Next, we measured whether it could be detected without problems outdoors. As a result, except for the 2 made by Panasonic, it was misdetected and could not be measured. False detections within 1 minute are not measurable. Check out any park or video. The day of the measurement was a clear sky with no clouds. According to the information on the weather site, the temperature in the measurement area was 20 C and the breeze was about 1 meter per second, and it actually felt like that. Move on. This is the detection range of the Panasonic sensor. Generally according to specifications. As for the measurement method, we checked whether it was detected by moving 1 step. However, since the horizontal and vertical installation standards are measured by eye, the accuracy is slightly low. Even so, the results are generally satisfactory without deviating significantly from the specifications. Move on. Sensors are usually installed in shaded areas, such as under roofs, so we measured in that situation as well. The results were the same because the measurement points had the same conditions of sunlight. Even if the sensor is in the shade, I think it is difficult to use the 3 sensors outdoors. Move on. Then I measured it indoors. I checked whether it was detected at a distance of 1, 2, 3 meters in the front direction. Regarding Panasonic products, 3 meters was detected without any problem, but the remaining 3 could not be detected at 3 meters, or the detection was about 50%. It seems that the movement is small and difficult to detect when it stops after moving about 50 centimeters. I think that the result will be different if it is a motion that keeps moving. However, since the performance difference of the sensor will appear this time, the measurement in this operation will be the result. Move on. Finally, we summarize the measurement results. We have compared the contents of the measurement object, the external environment, the detection accuracy, etc., and Panasonic products came in first and second place. The EKMC 1,603,111 was the first place because it was able to detect both the long-distance type and the short range with high accuracy. The distance is a little shorter in the front direction, but the second place EMKC 1,601,112 gave similar results, so I felt that either would be fine. The above is the measurement result of the motion sensor. We will continue to take on the challenge of making things using IT like this, so please give us a high rating and subscribe to the channel. See you next time.